We live on Earth, one of the 8 planets that make up our solar system. This solar system is located in a galaxy known as the Milky Way. Ancient Greek astronomers gave the name Galaxias Kyklos to our galaxy, which translates to Milky Circle. This name was given to our galaxy because it appeared from Earth as a glowing arc with a milky white color. Later, it was observed that the shape of the galaxy was more like a straight line or path. Therefore, the current name of the galaxy became a description of this appearance. Now, in almost all languages, the name of the galaxy is a literal translation of the term the Milky Way. The Milky Way is one of billions of galaxies that exist in the universe. The exact number of galaxies is unknown, but astronomers estimate that there are between 100 and 200 billion galaxies in the universe. These galaxies are classified into different types based on their shape. These images show some examples. The Milky Way is a spiral galaxy, which is the most common type of galaxies in the universe. The center of our galaxy, like all galaxies in the universe, is a supermassive black hole. In the case of the Milky Way, this black hole is known as Sagittarius A star. The size of this black hole is incredibly huge, as it is 4 million times larger than our Sun. Due to its enormous size and gravity, the components of our galaxy orbit around this black hole. The galaxy rotates at a speed of 230 kilometers per second. Since our galaxy is massive, it takes about 230 million years to complete one full rotation around its axis. And since the age of our galaxy is 13.6 billion years, this means that our galaxy has completed only 59 rotations around its axis since its formation until now. Spiral galaxies are characterized by the arms extending from their center. Due to the rotation of spiral galaxies around their axis, these arms take a spiral shape, which is the reason for the name spiral galaxies. The arms of spiral galaxies can be of different shapes. The system currently used to classify spiral galaxies based on their arms or to classify galaxies in general is the Hubble sequence. This system was developed by the astronomer Edwin Hubble in 1936. Hubble divided all the galaxies into 4 classes based on their shapes. These classes are elliptical galaxies, lenticular galaxies, spiral galaxies, and irregular galaxies. Elliptical galaxies are oval in shape, but differ in their degree of elongation. Accordingly, Hubble classified elliptical galaxies into 8 types and gave them the symbols E0 to E7. The second class is lenticular galaxies, which are disc-shaped galaxies. This class of galaxies is symbolized by the letter S0. The third class is spiral galaxies, which are characterized by their arms, as mentioned earlier. This class of galaxies is divided into 2 types, barred spiral galaxies and unbarred spiral galaxies. Barred spiral galaxies have a straight bar of stars around their center, unlike unbarred spiral galaxies. Both types of spiral galaxies have arms that extend from the center, but in unbarred spiral galaxies, the arms extend directly from the center, while in barred spiral galaxies, the arms extend from the ends of the central bar. Unbarred spiral galaxies are symbolized by the letter S, while barred spiral galaxies are symbolized by the letters SB. The arms of spiral galaxies differ in their structure, therefore, Hubble classified these galaxies into different types symbolized by the letters A, B, and C. Hubble believed that galaxies evolve over time, transitioning from one class to another. He believed that all galaxies in the universe were of the type E0 in the beginning. Then, galaxies begin to stretch over time until they become type E7. After that, they transform into lenticular galaxies and then into spiral galaxies, whose arms expand and diverge until they become type SC. This theory is known as Hubble's tuning fork, because the graphical representation of galaxies' evolution resembled a tuning fork. This theory suggests that all galaxies in the universe will become type SC after billions of years. Later, this theory was found to be incorrect, as elliptical galaxies cannot transform into spiral galaxies in any way. The reason is that elliptical galaxies are stationary and do not rotate around their axis, unlike spiral galaxies. Physically speaking, elliptical galaxies cannot spontaneously begin rotating on their own. Thus, They cannot become spiral galaxies. Although Hubble was wrong about his theory of galaxy evolution, the symbols that Hubble developed to classify galaxies are still used today. Later, in 1959, the French astronomer Gérard de Vaucouleurs extended Hubble's system of galaxy classification. This new system is known as the de Vaucouleurs system. Among other things, de Vaucouleurs classified newly discovered types of galaxies. In brief, de Vaucouleurs divided lenticular galaxies into two types, S0a and S0b. The symbol for unbarred spiral galaxies was changed from S to SA. Two new types were added to the spiral galaxies, symbolized D and M. A new class of spiral galaxies was added, which is an intermediate class between barred and unbarred classes. This new class is also divided into 5 types. The de Vaucouleurs system included other details that we don't have time to mention. Let's move back to the Milky Way. Our galaxy is of the type SBC, and it consists of 2 major arms. The first arm is called Perseus, and the second arm is called Centaurus. In addition to these major arms, our galaxy has several minor arms, including the Norma arm, the Sagittarius arm, and the Orion arm. These names correspond to the constellations in which the arms are tangent to our line of sight. Our solar system is located in the Orion arm. The length of the Orion arm is 10,000 light-years. Our Sun is 28,000 light-years away from the center of the galaxy, while the length of the entire galaxy is 100,000 light-years. A light-year is an extremely vast distance. To imagine it better, let's take a closer look. The light travels at a speed of approximately 300,000 kilometers per second, which is known as a light second. A light minute is the distance that light travels in 1 minute. The distance between the Sun and Earth is approximately 8 light minutes. A light hour equals this distance. A light day equals this distance. A light year is this distance. The nearest solar system to our solar system, Proxima Centauri, is approximately 4 light-years away. This is the distance that light travels in 100 years. The diameter of our galaxy is 100,000 light-years. Thanks for watching.